Hey gang, I know some people wanted a little bit extra practice with solving some exponential equations by using logs. So we're going to take a look at three more problems here. I've got two of them up on this first slide. So the first one, we have 250 equals 100 times 1.02 to the x. Now our first step here is, well, first of all, we're trying to get x by itself, trying to solve for x. So we have this 1.02 here, but before that we've got the 100. And so we have to get rid of that 100. So the first thing that we're going to do is we're going to divide both sides by 100 to get rid of that. So 250 divided by 100 is 2.5. 100s cancel there, and we have 1.02 to the x. Now, anytime we've got our variable and an exponent here, and we need to get it down, we're going to use logs. So we can take the log of both sides. If we do it to one side, we have to do it to the other side. So if we take the log of 2.5 and the log of 1.02 to the x, the power property says that we can take that exponent and we can move it to the front of the log. So this is going to look like log of 2.5 equals x times the log of 1.02. That's our power property. If there's an exponent on our argument, 1.02 is the argument, if there's an exponent up there, we can move it in front of the log. Likewise, if we were starting at this position here, we could take the x value that's in front of the log. If you're multiplying log times something, you can move that coefficient and put it up as an exponent on your argument. So you can go either direction with the power property. Okay. Now, we're trying to solve for x. X is being multiplied by the log of 1.02. So to undo the multiplication, we would divide by the log of 1.02 on both sides. So that's going to cancel out on the right side and just leave us with x. On the left side, we just need to take the log of 2.5 and divide it by the log of 1.02. And you need to make sure that when you type it into your calculator, you want to make sure that you close the parentheses. So your calculator is going to put an open parentheses here. You want to make sure that you close that parentheses before you divide by the log of 1.02. Okay? So when we divide by the log of 1.02, we get about 46.3. Okay? And you could always check out that answer, make sure it works, take 46.3, plug it back in up here, and make sure that you get that the right side equals 250. All right, this problem over here on the right, a little bit more complicated because now we've added this 90 to the end of the equation. That's an asymptote. So the first thing that we have to do is we have to get rid of that 90. So we subtract 90 from each side, and 180 minus 90 is 90, equals 110 times 0.9 to the x. Now this problem looks just like the one that we just finished. So the first thing we have to do now is we have to divide by 110. Okay. 90 divided by 110, I'm just going to leave that as 9 over 11 for right now, equals 0.9 to the x. Again, we've got an x in our exponent. We want to get it down. We have to use logs. Log of 9/11 equals log of 0.9 to the x, but I'm going to take that x right away and I'm going to move it down in front of the log. Okay. So now I have log of 9/11, and to get rid of the log from this side, I have to divide. So I'm going to divide by the log of 0.9. Okay. So the log of 9/11 divided by the log of 0.9 is approximately 1.9. So that would be our answer there. Okay. One thing to keep in mind, logs don't cancel by themselves. You can't just, it'd be like saying you have the square root of 15 over the square root of 5, and you just canceled out the square roots and left it as 15 over 5. It doesn't work that way. Okay. All right, let's take a look at one more. So this one will be similar here. We've got our asymptote. So that's the first thing that we need to deal with. So subtract that asymptote. And 358 minus 311 is 47. Now we need to get rid of this 293, so we divide both sides by 293. 47 divided by 293 is about 0.16. And again, we need to get our exponent down. So we're going to take the log of each side. Log of 0.16 equals log of 0.75 to the x, but I'm going to bring the x down in front of the log. So now log of 0.16, and I need to divide by the log of 0.75. So the log of 0.16 divided by the log of 0.75 comes out to be approximately 6.37. Okay. And just to show you as a check, let's plug that back in. 358 equals 293 times 0.75 to the 6.37 plus 311. And I'll just do this step by step here. So 0.75 to the 6.37. Now I'm going to round all of this intentionally just to show you that it won't come out to be exactly the same, but you should see that it comes out to be pretty close. So this is about 0.16. And then if we multiply 293 times 0.16, we get 46.88. And then if we add 46.88 to 311, we get 357.88, which is about 358. So the only difference, the only reason we didn't get exactly 358 is because we rounded this 0.16 here, we rounded this 6.37 up here, we maybe rounded some stuff along the way when we did our initial work to come up with our x value. Okay. So again, when you're given an equation, an exponential equation like this, and you need to solve for x, subtract off your constant term at the end here, the asymptote, divide by your a value, your starting value, and then to get the exponent down, you have to take the log of each side. Once you've taken the log of each side, the exponent comes down in front, and then you can divide by the log that's with the x. Okay?